Okay, I'm going to give in this video a very brief introduction to this method Electre IS. And we're introducing the method by looking at one particular case study. But I think you can go through this and apply the same procedure to any other case study. The procedure is mapped out step by step. And the idea of Electre is also a multi-criterion decision-making method, the same as Promethee. In this case, however, there's not multiple decision makers, but there are still multiple criteria. All right, so as I said, I'm going to go through this very quickly. So here are the references here. These references are available on Blackboard. Okay, whoops, I got to change something here. Here we go. Okay, now what's going on in this system? The system is concerned with development of undeveloped area in the Philippines. And there's economic and environmental ramifications. And you want to find what's the best development strategy. So the different strategies are here. This is again similar to Promethee. The strategies and their abbreviations. The criteria are listed here. Some have to do with economics, some have to do with environment. And then there's a table that expresses the consequences of each development strategy with respect to each criterion. And there are different units for each one of these columns. You can see what the units are down. The units are explained somewhere. Let's see. All right, so they're explained in this area here. It says what the values are. All right. All right, now in order to implement the model, there are various things you need to define. And it may seem that these are somewhat arbitrary. This is kind of the art that goes along with the science. But you need some way of ranking the effects of these different criteria. So in this case, for each of the criteria, in this case there are 6 criteria, for each one of the criteria you need to define an indexing function, and that basically scales the data between 0 and 10. 0 is good, 10 is bad. So for instance here, PR, whatever that is, the value goes from 0 to 165. We want to scale those numbers to be from 1 to 10. No, I'm sorry, I got that backwards. Revenue is this way. So scratch that. Revenue is this way. Each number in this column is measured in the same units, and you want to scale these numbers to between 0 and 10. Now, it's not necessarily that 0 scales to 0, but you just need to find some scale that ranks these numbers to ranks between 0 and 10. And the same with every one of these alternatives. Every row corresponds to a different factor, a different criterion, and so you have to rank each criterion from 1 to 10. Now there are a number of thresholds to define. The first one is called a preference threshold. And let me give an example. All right. Let me give an example of this. Remember that all of the criteria are scaled from 0 to 10. So let's say that the strategy A has G of, let's say G1 of A is equal to 9. And let's say the strategy B, I'm using capital letters here, he uses small letters here, really doesn't matter. But suppose strategy B has G1 of B equal to 2. And let's suppose that the preference threshold for criterion 1 is equal to 5. Okay. So what that means is that here we have GI of A minus GI of B is greater than or equal to P. It's greater than or equal to P1. That means that alternative A is strongly preferred to B. Okay. Now, if I also had C, where G1 of C is equal to 3, and I still have P1 is equal to 5, because the difference between G1 of A and G1 of C is bigger than 5, I would still say that A is strongly preferred to C. So really, as far as this criterion, when comparing A and B, it's the same as comparing A and C. I don't say, in this comparison, I don't say C is better than B. Compared to A, they're both strongly preferred. So in other words, there's a limit to preference. You reach a point where one is so much better than the other that you say, as far as this is concerned, this one is very strongly preferred. Okay. On the other hand, we also have an indifference threshold that says, okay, if I have two alternatives and one is only slightly worse than the other, then for all intents and purposes, these two alternatives are equivalent with respect to that particular criterion. Okay, I could give an example for Q. So let's make some space here. Well, let's just do it here. If I take some example, if I say G1 of A is equal to 5, and G1 of B is equal to 4.7, and suppose my indifference threshold is equal to 0.5. Okay, then notice that the difference between G1 of A and G1 of B is 0.3. So we have G1 of A minus G1 of B. That's less than or equal to 0.5. So we would say that B is insignificantly worse than A. In other words, there's really not the difference is so small, there's really no reason to recommend A over B as far as this criterion is concerned. Okay. Now there's another threshold called a veto threshold, which says that if one alternative is so much worse than another, that's so much worse that we can simply say that the second criterion is disqualified from consideration. Okay. So, for instance, if I had G1 of A is equal to 9.5 and G1 of B is equal to 0.5, I'm sorry, is equal to 0.3, and suppose that my veto threshold was equal to 9, then that means that B would be disqualified, and B could not be my final choice. Okay. Now, it's possible to set these numbers differently. If you don't want to have a veto, you could set V equal to 12, for instance. If V was equal to 12, then this condition would never be satisfied, and you would never veto. Right. Finally, you need to assign a weight for each criterion, which measures how important, the relative importance of each criterion. If you think a criterion is very important, you'd assign it a large weight, and if it's not important, you'd assign it a smaller weight. It's not really necessary for the weights to add up to 1. They could add up to 100. In the end, you'll end up dividing by the sum of the weights, so it will end up being a fraction. So in addition to these variables, you also have to define the following variable for the entire system, a concordance threshold, which basically, once you compute all the relative effects of the different criteria, you have to, and you'll get one single number, and you match that one single number versus S. And if that one single number is bigger than S, then you can say that one alternative is preferred to another. All right, now, in order to carry out Electre, there's a step-by-step diagram here. And we've already developed the alternatives and the criteria. We talked about the indexing function. We've talked about how to compute these values, and we've talked about the definition of these variables. Now we're up to this point of computing the concordance indices. And then once we've computed that, there are a few computations we need to carry out, and that will give us our final result that either one alternative A outranks B, it does not outrank B, or alternative A does outrank B. All right, so here we go through the detailed implementation of this model for that particular case. This talks about the choice of the indexing functions. This talks about the thresholds. This talks about how you compute the concordance index. The concordance index is going to help you find this. This concordance index is what is going to determine whether A is better than B or not. Now, the concordance index for comparing two alternative strategies is computed on the basis of concordance values for each individual criterion. So for each criterion, I need to compute this value, and this value has different different values depending on the range of the index functions. Okay. Now I can represent this function graphically. This is actually a function of two variables, and you can see that according to the region, we're going to get a different rule for this function. So that's why we look at this diagram here. In this white region, we have that the concordance value is 1. In this blue region, the concordance value is 0. And in this gray region, the concordance value is in between. All right? So you'll have to compute concordance values for each index. Okay. All right, now once you've computed the concordance values, you take the weighted sum of the concordance values to get the concordance index. Okay. And then you judge the relative, how can I say this? The relative concordance of the two alternatives according to these three conditions. I should probably write down this formula for CAB explicitly. I'm not sure if it's here somewhere, but according to this, it says that CAB well, here's what it says. We take the concordance values found when comparing alternative B, multiply them by the corresponding weights, and dividing by the sum of all weights. Okay, so if I was going to write that out, that would be CAB is equal to the sum from I equals, in this case it's 1 to 6, CI of AB times WI, and then you divide that by the sum of the weights. I'm sorry, this is incorrect. It should just be WI. Okay, so if you want a formula written out, this is your formula. Now let's make that a little bit nicer. Don't need the crossouts there. This is just the sum of WI here. Okay, so that's it. Have fun reading that selection.